Hello everybody, and welcome to 21st Century Woodworking, with me, your host, Dirk the Engineer. Hello everybody, Dirk the Engineer here with 21st Century Woodworking, and today's little project is a gizmo for your CNC. I think a lot of us have seen people use these blank PCBs as touch plates for their Z-axis homing or zeroing, and essentially all you do is ground your bit, set this down on the table and let your bit touch it, and then you know exactly where your position is. Well, I was kind of thinking about all this and thought it would be nice to have a holder that I could mount somewhere on the side of the machine head where it would be nice and close and convenient. And so I came up with the design, and this is made out of some scrap maple, and the printed circuit board blank fits snugly into place here, and I can still have room to have my wire soldered to the plate, pull it out, set it down and go, and then put it back and go. So everything is a nice workflow, quick and easy, and located at the place where you would need it, where the machine head is when you're setting up your jobs. So this is the finished one, and I have a blank here that I've made, done some tests. It is made out of two halves. One is just a simple pocket. All of us should really know how to do that. The other side has some raised features which register it in the pocket. It's got a raised feature here which squares out the bottom so that you're not hitting rounds on the side with your circuit board. And then it's got a little raised tongue here, and that is what registers and kind of provides a little bit of spring force to hold your plate in there and keep it from vibrating or moving around or falling out on you as you're machining. Pretty easy. It should take you about an afternoon. I'll post the G-code, or I'll post the VCAR files on my site for you so that you can do that. And yeah, without further ado, I think we should get started. So enjoy. Okay, the first thing that you're going to want to do is find a scrap piece of wood that's big enough for your project. I happen to have one that I ripped out of another project here, and the piece has to be roughly 4 inches wide by 7.5 inches long, the way I set up my G-code. That way I can get two pieces, the two halves of the holder out of this way, and have the grain running this direction, which is what you want to have. So this is just a scrap piece of hard maple. It could be any kind of wood. I just like this stuff because it machines fairly well, and it's easy to work with. So I've got my bandsaw set up, and the first thing that I'm going to do is rip off this edge to give me a square and true edge, and then I'll rip it to width. And because as you can see, this edge isn't square either. This board had a cup in it, and so I kind of cut it in half and made a couple different things out of it. So, and then what we're going to do is we're going to resaw it to a little bit more than 3/8 of an inch, and finish off the thicknessing with my drum sander. So here we go. Set up the saw here. Okay, that looks pretty good, and I'm not too concerned about this. I mainly just want a square edge so that I can get the other end nice and square and have something good to write against. And one thing I'll mention too is that usually you want to square your blade to the table on this side, because the split side of the table where you put your blade in usually can have some a warp in it, so it's good to work off of this side of your blade whenever you can. So here we go. I'll just lower the guides down some. so I don't need them to be that high. Go ahead and tighten that up. Make sure that I'm touching the blade there with the guides, and I got good clearance. So here we go. Where's my push stick? Here it is. Always recommend using a push stick whenever you can, unless it makes the cut more awkward and you feel more dangerous by using it. But here we go. Forgot to turn the dust collector on. Okay, not a bad cut. Now we'll go ahead and grab my steel rule and set up for the final width rip. Alright. So one thing I like about this Drift Master fence is that I can have this precision screw system on here that allows me to very accurately adjust the fence. I can lock it down. Alright. So here we go. Dust collector on. Okay, I love working with maple. I like that side of the grain there. It's always pretty. Okay, so next we're gonna see how this is cupped like that. That's not so great for resawing. I think I'm gonna put this through the sander to get a flat face to work with here. So let's go ahead and do that. I want to flatten this out a little bit, and a great tool for that is either a drum sander or a planer. For really small pieces of wood like this, I find that the sander is actually easier to work with because I don't get board snipe, and it's a little bit safer. It takes a little bit longer, but you can get good results with this too. So I want, because of this check here, I want to cut against this side of the fence, so I want to flatten this out. And so I'm just going to go ahead and put that through the drum sander, and we'll see how flat we get. One thing with working with the sander, you always want to make sure you have really good dust collection because it makes a lot of really fine dust. So always make sure you've got this on and the dust collector on when you go. Okay, that looks pretty good. I've got almost all the saw marks. Maybe I'll give it a couple more passes here. Okay, that looks pretty good. That should be good and flat now. Let's give it a check. Alright, we're looking good. Looking good. Now you might not think of something like this that, you know, can give you a bow, or, you know, if the board has a bow and it could rock back and forth. But what I found is that the drum sander with the rollers naturally likes to keep the workpiece as flat as it can as it goes through, because there's pressure on the top. So it generally gets me nice and flat and ready to go. So with that, let's go back to the bandsaw and we'll rip it down, and then we'll come back to the drum sander and we'll do something for final thickness. So okay, so I've got that face is nice and flat now. It doesn't really rock against the fence too much of any great extent. And so now I've got the fence locked in at just a little bit over 5/16 of an inch. We need the final thickness to be 3/8 of an inch and to be nice and flat. So we'll rip it down or resaw it on the bandsaw, and then go back to the sander and get her nice and flat so that she can go over on the CNC machine. So without that, you notice I reach into my pocket. I'm grabbing this remote and turning the dust collector on. That's really handy. It saves you a lot of reaching down and running back and forth. So I'd recommend it. It's a good investment. There we go. Okay, so that does a really nice job. I've got a nice straight piece. It leaves a face that's pretty smooth. I'm not exactly sure what the deal is with this bandsaw, but actually it stopped right on this. No, that's not the weld. But it seems like the weld isn't as smooth as some of the other Resaw King blades that I've had, and so I get a lot more chatter as it goes through the guides. But it does a reasonable good job. A lot better than most bandsaws. A good bandsaw, along with these other tools that I work with, I highly recommend it. You can do just about anything you want to do in the shop with a good bandsaw, a drum sander, and a CNC machine. Those are really all you need to do for most things. So with that, I guess we'll go over to the drum sander and finish thicknessing this off. Okay, now we're just down to the final steps in our stock prep for putting it on the CNC. One thing I wanted to mention is after you cut something, it's not uncommon for the wood to bow or bend out of its original shape, even if you got it nice and flat to start with. That's because there's internal stress in the material, and after you cut a new surface free, if this piece had more bow stress in it than this piece, it'll warp. So it'll relieve strain or relieve stress and warp on you. So what you want to do is kind of put it on your table and look to see which is the flattest side to start with, and it looks like it's probably this side. And you'll end up getting it nice and flat as you take the material down. There is a pattern to what you want to do, though. You want to start on, let's call this side A, run it through, then turn it around, side B, and then, or in the other direction on side A, and then flip it over and run it through, and then run it through again. And if you do that, especially as you get closer to the final thickness, you'll end up with a very nicely uniformed thickness material. Kind of a trick I picked up. The other thing that you do want to do before you start is get the gantry as level as possible, or in the same plane as the table. And you can do that by adjusting this knob. Now this is a Performax. This is a little bit older machine. It's the same machine that you'd get from Jet or Powermatic or any of these others that have this open-ended design. It's a good design. It's gotten really good reviews. Now what I usually do to start, before I lower the head down, or before I turn the head on, I usually start the table up and I open up the machine. It's a little hard to do this with the hose connected, so I'll just disconnect that. And I usually just keep lowering this down until I start to see the head move with the on the piece as it goes through. Like that. That was pretty close. Let's see if it does it again. Alright, so it's just catching on one side of the board. And that's what you want to do. That's where you want to be at your start. So I'll go ahead and hook this dust collector back up. Get her down. Okay. Here we go. So I do quarter turns on this, usually, and that's enough not to stall the motor. So I'll go ahead and do this again. Another thing that you'll see me do is hold the piece down with my thumb while it's feeding in, and hold it down again with the thumb when it's coming back out. The reason that I do that is it'll tend to lift, and you don't want to do that because otherwise you end up with snipe on your material. So I'm just taking this down until I get rid of all my saw marks first. And if you follow that pattern, you can get it really nice and close. It's got to be 375. I got it a little undersized, which is alright. It's pretty uniform, pretty uniformly thicknessed. That's a little bit, there we go. It's not uncommon for the very edges to be a little bit thinner. So it's within a couple thousandths the whole thickness, and it's nice and flat. And that's okay. If it's undersized a little bit, it's not going to hurt anything. So I think it's pretty well ready to get over on the CNC machine and start machining. So I'm going to go ahead and do that. Pretty well set up. I've got my locating pins in the table. I've got the carpet tape on the piece of material, and ready to stick it down and get going. So I'm just going to locate it against these two pins and then drive it down against this pin, and then force it down onto the table, and we should be good to go. Get it good and stuck down so it ain't going to move. We probably need a plier to pull those pins. It is important to have those pins be tight so that you're locating to the same spot every time. Okay, so I got those pulled. Alright, so those are pulled. Got it good and stuck down. It doesn't look like it's moving at all. Alright, so I'm going to go ahead and move the head to 0, which should be at the top corner. So what I do usually is reference 0 on this table and then move the, put in a, in the Z value like minus 0.375, and that gets me up to the top here. It looks like it's good enough. I think I can go ahead and get the dust shoe on and start the program. Alright, that's good to go. Let me just make sure I've got the right program loaded in here. Okay, that looks good. Okay, got power to my VFD, and one thing I did want to mention is that you're actually going to want to get a pair of calipers out and measure the diameter of your bit. Reason for that is oftentimes they're undersized, and if you're doing pocketing moves like we're actually going to be doing in this that have to fit together, if the bit diameter is smaller than what the machine code thinks it is, you'll end up with a really tight fit and maybe have a little bit of misalignment. So yeah, I measured it and it was 0.184 and 3/16 is 0.1875. So a few thousandths there. It could make a difference when you want to try and get a nice snug fit. So anyway, we'll just go ahead and see what she does. Okay, well, let's see how we did. Get this scrap out of the way. And carpet tape is really sticky, which is, why people use it. Got a little bit of chip out there. I could modify the path so that the first thing that it does before it cuts the pocket is cut down in beneath here to prevent that. But all in all, I think it turned out alright. Let me grab my scraper to try and get this off. Let me see here. Okay. Get it underneath the corner there and pop it up a little. Alright. Turned out pretty good. Not bad at all. Right, well, these pieces are going to fit together like so, like a glove, as Ace Ventura would say. And let me do a little bit of cleanup on here, and I'll show you how they fit together and get them glued up, and then we'll do the final steps, the profiling. So, okay, well, I spent a little bit of time getting the two halves cleaned up, and they go together really good. Getting that bit diameter correct is very, very important, because if you don't, if the bit is smaller, you'll have trouble getting this to snap in place. As it should go, you should actually, when you press on it, I pressed the wrong way there. When you press on it, they should just snap together. It should hold together, and then the top and bottom edges should be flush. That's how you know if you've got your bit diameter really good and correct. If you don't get it quite right, it's not a big deal. I mean, we're gonna put a profile around the outside, and that's gonna make these edges exactly flush and hide that glue line too. So it's not a big deal. So the next thing that you want to do is get your Z touch plate out, and you want to put the good side facing this way, and the bad side facing the tongue there. And you just want to slide it right in. What you want to have is a slip fit. It's got to be loose enough that you can get it in there. The wood should provide a little bit of spring to help hold it in place, but you don't want it to be loose and vibrating and rattling around. If it doesn't fall out, that's probably pretty good enough. I designed it to be a little bit tight. See how good and tight they fit together. It's hard to get apart. If it is a little bit too tight for what you like, just this tongue is what's holding it in. Just go and get some sandpaper and work on your fit a little bit. It works pretty good. The other thing that I like to do is take the top of the tongue and just put a little camphor on it so that it helps your material slide in. And then just go ahead and fit your pieces back together. What you do want to do is make sure that when you're doing your test fits that it's good and snug, that these edges are touching, because that's what's going to register everything together. And you just go ahead and do your test fits. That's pretty good. I like it there. Now what you will see, and I say you want to use this side, is because it will wear on that a little bit, and that's no big deal because we're going to indicate off of this side, and having a little bit of a dip in something isn't bad. As any good machinist will tell you, it's not the low spots that matter, it's the high spots. So it should still sit flat, and you know, you can touch off here, and then what you're going to do eventually is solder a wire on here. So you want to make sure that you have enough room when it's in that you can get a wire on there. And then I like to I'll put a little hook or something on there and wrap my thing around and pull it up a little bit and keep it tight, so the wire won't move around when it's machining. But then if you mount it on the side of your your spindle mount, it's always right there. You can just pull it out, set it down, and go. So fun little project. Take you an afternoon maybe once you get everything set. So all we got to do is glue up, and we'll be ready to go. So you guys can figure out how to glue. Not a big deal. It is hard to get this thing apart. It doesn't go together hard, but it seems to come apart hard. So obviously you don't want to get glue on this surface or on the interior surface here, because it's going to mess stuff up. But once you get it glued up, you're ready to do the final machining, the profile machining, and finish the project up. Okay, so the final thing that you're going to want to do with this is put a nice profile around the outside. If there's any misalignment that you got either during your glue up or because there was a mistake in how you set up your first machining steps, this will take care of it and hide it, make it look nice. One thing is, after you glue up, you're going to want to go in and figure out how you're going to orient this thing and make sure that those two sides are scrape free of glue so that they don't stick out. Now I've got pins set up on my fixturing system so that I can reference it, and I know that if I put the G56 command in there, that my work offset will put the bit right over this corner. So that really helps on setup. I'd recommend doing any kind of fixturing that you can. I've already got the carpet tape on. I've got the G-code loaded. I've got my 1/2 inch bit in the chuck, and I'm ready to go. So I'm just going to go ahead and stick this down. Okay, it's located tightly against these two pins and against this one. So now I know it's square on the table. I know where the position of this corner is relative to my code. And sometimes these pins can be a little bit tight. I think I'm going to have to grab a pliers to get them out. If you have a soft jaw pliers, I'd recommend using those so that you don't mar up your pins, but I know I don't have to pull very hard to get them out. You do want them to be nice and tight like this, though, so that there's no slop when you reference your system. So now that's good and stuck down, and it's not going to move anywhere, and I'm ready to machine. So I'll just go ahead and get my dust shoe on. Here we go, that's on. Alright, go ahead and start my vacuum, and I'll start my G-code, and it'll go and get the profile on there that I want. Okay, so now I just got my scraper here. Just try and work it under one edge and pop it up. And we're pretty much done. Just a little bit of final sanding. You can see that it's all nice. You can hardly even see the joint now. It should be pretty well ready to go. The carpet tape will come off nice here. And I'll give you a shot of it when it's done. But it should hold my Z-plate nice now, and it's going to look nice. I'm going to mount it up on the spindle carriage, and it'll hold my plates really nice. So that's about it, and I guess till next time, I'm Dirk the Engineer. Remember to like and subscribe, and I'll see you guys soon. Thanks.